I think we can start, right? We are 1 minute beyond, and I don't want to take more time from Sonja for our awesome presentation. So welcome for the first session here on this stage. I'm David. I will guide you through today during the different sessions we have here. And I'm very happy to have the first one here from Sonja. She's Group Product Manager at a company called Tyke. So who knows Tyke? Who knows the products? Okay, nice. So they, they're very deep into this whole kind of API gateway, API management thing. And that's why I'm very happy that we have Sonja here today talking about bad API observability. So give a hand of applause to Sonja and welcome on stage.
Thank you. Thank you. So first, I want to say it's so great to see so many familiar faces and to have a KCD here in Austria. I live in Linz, so know many of the people here, and it's so awesome for the community to be there. So welcome for the whole organizer, for all the organizers. So I'm Sonja. I'm a group product manager at Tyke. And Tyke, we do API management, API gateway, and we have recently released our support for OpenTelemetry distributed tracing in our own API gateway. And as the team was working on adding that feature, I, as a product manager, was busy talking with customers and with users to understand how they will use it, what will they do with it. So I run 10, 15 customer sessions to really understand and the problem, what they do with APIs, how they monitor it, how they're troubleshooting it. And I realized there was a lot of room for improvement. So I started talking about those issues, and that people were having monitoring and troubleshooting their APIs with other members of the community, in the cloud native community. And I was invited by Stephen Townsend to his podcast, the Slight Reliability podcast. Have you ever heard about that podcast? A couple of hands. So it's a really cool podcast about SRE and observability. I really recommend it. And Stephen, he had published a blog post called Bad Observability. And that blog post that really spoke to me. I found it was really good. So when we came together and talked, we decided to do an episode about bad API observability. And so this is the inspiration for the talk today. Thank you, Stephen. He's in New Zealand, so he won't see us today, but maybe he will get the good vibes. Now at this point, you might wonder, Sonja, is API observability really a thing? Or is just one of those marketing terms that you're trying to just introduce for us to think about? And I'd like to start by giving you 3 reasons why API observability is important and we need to think about API observability. Reason number 1, APIs, they have become the building block of our digital world. You start a new project, you would never start it from scratch, you use API to build upon. So when anything falls down in one API down the line that you're using, your whole user experience crashed. If it's slow, your whole product is slow. So you're relying on multiple different building blocks, and if something happens, it's damaged your whole your user experience. But also, APIs are becoming much more. APIs are becoming product. Nowadays, you have companies like Stripe or Twilio. They don't self-user interface. They don't have an app. They have APIs. And now APIs is a way to make money. Even old school companies, old banking, they are all going through API. Fintech, health tech. There's a lot happening there as APIs product. And again, if you're selling APIs, you need to be able to make sure that they're reliable, that you are able to have a good user interface. And in the latest Postman State of the API report, 43% of the participants said that API generated over a quarter of their company revenue. So there's something happening here, and we need to make sure that we have the right tools to understand how to deal with the APIs. And if those APIs go down, your company will lose money. And the third point is because APIs, deploying APIs to production that demand cross-functional teamwork. From the architects that define the general architecture and the guidelines, using REST, gRPC, GraphQL, WebSocket, gRPC. The API platform team that is responsible for managing the gateways, including the whole authentication, authorization, weight limiting. the different developer team that implements the API and the product manager responsible for the adoption and the monetization of the APIs. All those people, they have to work together to create a valuable API experience. And I'm convinced that with modern observability, we can help them to avoid all the anti-patterns we are going to discuss. Before we go a bit deeper into those anti-patterns, I just want to give you a couple of pictures, diagram in mind to see what are we talking about. In those examples, I'm going to use very, very simple architecture of different services that are proxied by an API gateway. Why should you use an API gateway when working with APIs? Because it helps you to simplify and centralize operational concerns like, again, authentication, authorization, API versioning, deprecation of API, rate limiting, and it enables the developer to focus on building the value, the thing that is special to your company, not all those things that are needed for the operational. And in my example, I'll have a pretty easy, simple open source observability stack that is straightforward. So API gateway and the different services are sending span are instrumented with OpenTelemetry, and they're sending span to an OpenTelemetry collector. The OpenTelemetry collector then forwards the spans to Jaeger, a famous, well-known open source tool in the observability space. But also there is a component on the OpenTelemetry collector that I'm using. It's called Span Metrics Connector. It enables you to generate data from your traces. Things like error rate, error, number of error, latency for your calls. And those data are exposed as a Prometheus metric endpoint that is then getting where Prometheus gets the data. And you'll see I have a Grafana dashboard that uses this data. OK, so we can start now. 7 observability anti-patterns when working with APIs. The first one that I have is relying on API monitoring only. So when talking with customers, we saw that many API teams were not really talking with the developers on the backend side, and they will just use API monitor. And using only API monitor to understand if your API is stable is a bit like looking at your house that is on fire, but just looking at the fence, wow, nice fence, everything is going well. You're not seeing what's happening inside. What is API monitoring? Actually, it's a fancy word to describe automated tests that runs into production. It's just making tests, is this working, is this working, is this working? And because it sends those automated test requests to the API endpoints and then verify the response, it can be helpful to track the health of your APIs, even when there's no user activity at all. And most often you see them in SLA report, uptime report, all is good, it's online, it's responding, but actually you don't know what's going on. This is such an example. So this is an API monitor from Postman. You can go in Postman, define API monitor for your request every hour, every minute, send a scroll, and then, wow, all is good, it's green. Great, good job. Are you really sure? Let's see what my observability stack is telling me. OK, from 74 requests, 41 errors on the server side. And this is the reason why you should always use observability inside to understand what's going into your system. Doing some random checks, some tests that you think, oh yeah, that's the test, and if it's up, it's all good, is never all good. You can never know how the user are using your product and what's really going on. So always use traces or metrics that are the internal from your services. Now, all good, right? We have this, we can monitor, we can fix it. OK, it's fixed. Now we're good, right? Now, you forgot your users. It's really easy to lose sight of the fact that API are built for people to use. And actually, when you think in terms of API, you have two kinds of different users. You have the developer that are starting to integrate with your API into the system. And there are the users that will interact with the application or the services that rely on your API. And if you can't understand how they interact with your APIs, you're missing half the picture. So when developers integrate with an API, how long does it take them to make their first API call? What are typical errors slowing them down? observability plays a crucial role in surfacing insights to improve developer experience. And once your customer application or service relying on your API are in production, can you track how your releases impacted their request, which version of the API they are using, what are the most popular endpoints, are customer getting the same performance, same error rate? The first step to get that information is to separate errors, to not just look at errors, server-side errors, but also start capturing the client-side errors. So server-side error, typically, they are the HTTP 500 calls. And this is something that many SRE will just use, get automatically calculated in the observability tools, and like, okay, no error, no server error. Yeah, there are some client errors, but they're not really important for us. Yes, they're important, because it's a whole. If your user has problems using your APIs, it's a problem for the whole company, it's a problem for everybody. So one way to do it is to start tracking the client-side errors. Those are typically the response code in HTTP that start with 4. And here I have a couple of a bad request, unauthorized, not found, method allowed. You might say, yeah, but that's only users that are having problem with my service. Why do they have problem? When you start seeing an increase in those kind of in client errors, you need to go deeper and see, are we providing a bad sample code that has bad examples that are not working anymore because we forgot to update them? Did we deprecate the version 1 of our APIs and only allow the version 2, and still some clients are connecting to version 1? Another thing you can do is start looking at who is connected to your API. Usually when you work with APIs, you have authentication token. So what you want to do is, in your observability tools, also surface how many users do you have, how are they using your APIs, do we have different kind of user, premium user, gold user, do you want, how is their experience? And using those indicators, you can then use distributed tracing to get more data and see how you can fix and provide a better API. It's not always about reliability, it's also about developer experience. Next one, when we know, okay, now we have the data that we need, we're able to track how users are doing, we want to make them happy. If we get an error, if we see something is slow, what do we do? And in the API world, still too many people use API access log. And using API access log to try to find an issue, it's very cumbersome. What are API access logs? They are record of request and response made to an API that capture details like the IP address, HTTP method, the endpoint, the status code, and other relevant information for monitoring, debugging, and security purposes. Maybe you recognize this diagram. It's already maybe 7, 8 years old. It was Netflix who started to talk about microservices, but not today. This is how our systems look like. You have a mix of different versions running in different pods with different feature flag. And every time a new request comes in, you can never know exactly where it landed, unless at least with using just logs. And imagine trying to figure out why a specific API call fails by getting to that log, to that log, to that log, to that log on that pod, and trying to find them. And that's really what people still do. So we had that conversation with many users. Their service team, the dev teams, they call the API platform guy, and they say, hey, why is the API gateway slow? And no, it's not slow. So they start looking, logs at the side, logs on another side. That takes too much time. This is why we need distributed tracing. Because with distributed tracing, you see from the top to the start how much time is spent where, and if there's any error, you are really clear on what's happening, where is the error. And this is also why the distributed trace needs to start at the API gateway, the first things that get the request. We see also too many teams where API gateway team and developer team don't talk to each other. So the developer team, they will have the distributed tracing, but it starts only at the services, and there's a lot that could go wrong before that, before the request starts at the services. There can be an error with authentication. The authentication server can be done, can be slow. There can be a problem with rate limiting, with version deprecation. So it's always super important to start the trace the earliest as possible. Now, there's another problem that we often see as we talk with users is different teams working with different data and different tools. Now, different tools is not bad. It happens. You have major acquisition, a new team comes in, has a favorite tool, but the problem is when you start looking at an error rate and another team has a different measure for a different error rate. So how do you get those people to talk together? One thing that's super helpful with OpenTelemetry is the concept of observability pipelines. So imagine you have an example like this. You have an API gateway that exports spans, OpenTelemetry spans. You have service that export data to two different observability vendors. Because the team started like that, maybe a team is here in Vienna, another one is in Budapest. They started from two different companies, were acquired, and now have their own tool. But if you use a centralized API management tool, the gateway and your component, the whole infrastructure is usually centralized for the authorization, authentication. And those people, they want to know what happens. They want to understand the end-to-end from the user. Because again, when you deliver API experience, you want to know how much time is it, where are the errors, you want to see the end-to-end. So the solution with OpenTelemetry, and this is one of the reasons why I really like OpenTelemetry, is you can define observability pipelines. You can configure things like, okay, for all the traces for the API platform team, just send all the spans to Jaeger. If those are the traces for the API number one, the API that is managed by the developer team number one, then send them to an observability tool like Dynatrace. If those are API calls that are for the developer team number two, then just send them to Lightstep. And you can really be very, very granular with the data that you send, where. So you have that flexibility. How does it look like in practice? The OpenTelemetry collector has a YAML file in which you can configure those kind of things. And you can define the exporters. So where are you sending the data? The observability traces can be the same with metrics and logs. And then you can define pipelines per type, per teams, and define, okay, this team, this is the data that they need. This team, this is the data that they need. But also you can go further with observability pipelines. And what we have seen, especially in banking environments, the API team, they didn't want to forward everything to the user. They had, so a customer, they had a platform in-house, so their own observability tool in-house, and they would want to get all the data. And the developer teams, they had SaaS solution for observability. And that bank, they didn't want to send all the data, authorization, all that kind of information into the cloud for privacy, security, guidelines reason. So what they would do is just remove all the things on the trace, on the span that were not relevant for those developer team, but still provide them the end-to-end. And that's what's really important with observability, is that every team has access to the end data, the data that are relevant for them. And in OpenTelemetry collector, you can define the receiver. Where do you get the data from? The processor, what happens with the data? Do you remove data? Do you create metrics out of it? And where do you send the data to? The next anti-patterns is one-size-fits-all. When you deal with APIs, they are much more than just REST API. This is a graphic from Postman, state of the API. And of course, REST is the most popular API because it's really easy to use. But there are many, many different technologies that are being used nowadays. There are things like webhook, GraphQL. SOAP is still there. We still have lots and lots of services, legacy services using SOAP. WebSocket, gRPC, MQTT, and so on. And monitoring the observability is not always the same if you use a REST service or if you use something else. Just one example. If you remember how I was trying to capture the errors, because I want to see how my users are doing. I really want to understand what's going on with them. How can we make the developer experience better? Not only the reliability, but really the developer experience, making them happy, making them easy to use the API, and not having an API that is difficult to integrate because they will go to somebody else and another competitor that is providing them another API. But if we look at GraphQL, GraphQL is different. then doesn't just use the HTTP 500 or 400. So if there's an error in GraphQL, you send a this is a GraphQL playground. This is something that you usually get with a GraphQL server just to test the GraphQL server. And if you don't know about GraphQL, it's a query language for APIs. So you can, and the advantage of GraphQL, you can ask exactly what you need. So if you need only 2 fields from the whole API, you can just query for those 2 fields, a bit like SQL. And it was invented by somebody at Facebook, to make it really easy to communicate from the mobile and front-end application to request exactly the data that you need. And it's a great protocol, but there are things you have to know when you start using GraphQL in production. And the most important thing for us today is that when you have an error in the query, that the user make a mistake, the server is not going to respond with a 400 error code. It's going to respond with a 200, everything fine, and the error will be included into the response body. So the front end is able to parse it, but you on the server side, you will never know that something went wrong. You will not see the errors that your users are having. You will not be able to improve your service, provide better documentation, better demo code. So what you can do, and depending on which GraphQL server you are using, so you will see that depending which GraphQL server you are using, there won't be an error as well on the trace. All good, because it's only a client error. And in most GraphQL server, you have to add, so if you are building your GraphQL API yourself, you have to add a bit of instrumentation to report an additional error to the span. You can do it very easy, and hopefully the instrumentation are going to get better in the next couple of months or years. And then, if you report the error, you can see it, then trace it on Jaeger, see it on your traces, and also use, again, the metrics, build metrics out of it to report them and to be really proactive about your errors. That was just an example, but you have to really look for each technology that is not REST. You have to really think about what do you want to get out of it, what are the specific use cases, and how to get it. At the end, it's always the user experience that's important. So you have to be able to capture all those insights about your users and how they are doing. And the last anti-pattern is observability is for production only. And this we see quite a lot. Oh yeah, okay, observability is just for production, because it's the SRE team that implements it. We on the developer side, we don't need that, we have a test. That's wrong. And there's a couple of examples that I want to share with you today. One is, at TAC, we already use distributed tracing to also share information in case of error. So what we started to do since we have introduced OpenTelemetry is the developer are exporting the trace, the JSON trace. When you go into Jaeger, for example, you can click Save, and they're attaching them to Jira ticket. So I have an error, I spot something, and then they exchange the information. We no longer share, sometimes, yes, we share log files, but most of the time, when possible, when available, we share the trace. Because if I detect an error and I have the trace, it's so much easier for a developer later on to understand, okay, it went through this chain of middleware, this happened, this calls, okay, and I can reproduce it and test it much more easier. The second, and when you're in production, you can then avoid this, like developer just throwing things all over the fence and SRE team having to catch them. And another thing that I want to let you with is trace test. So we have Adnan here in the room, and he's going to do a talk in this room later on trace test. And I have to say, we are also using it at TAC. And this is a testing tool that is based on the traces. So if you spot something in production that is not right, you can use the traces to then create automated tests on it. We use it for our own OpenTelemetry integration to test how well and to make sure we don't break our own OpenTelemetry integration. But there's a lot of things that you can do on the API side as well. Test complex authentication flow, test caching, test GraphQL issues. GraphQL has an N+1 problem where sometimes when you send a request, then we'll send lots of call to other services. There are many, many things that you can do in this area. So that's all for me. Remember, user first, also for API. API is the things where they interact to, so we need to make sure to provide a good developer experience. And your availability is irrelevant if your users are upset. Forget about logs for troubleshooting API requests. Use hotel to break silo, make sure people have a same data set and are able to communicate and work together, and make sure to understand your tech stack. Thank you.
Thanks a lot, Sonja. Who of you is actually using distributed tracing? Just out of curiosity, okay. And who is building distributed systems? It's a lot more, I guess, right? So I think this was a nice intro.
He's not sure.
Every system is kind of distributed, right? So we have still a couple of minutes for Q&A. So are there any questions in the audience which you want to raise? But before we do this, let's quickly raise a hand of applause for Sonja's talk before we jump into the Q&A maybe. To also give you some time to think about questions. So who has questions? Any questions? Just raise your hand and I'll bring you the mic. We have a second mic even. So any questions? We have 2 mics for questions.
I have stickers.
You have stickers? So what's the question to this, right? Okay. Yeah, there's one.
Super. What is your take on synthetic user behavior monitoring?
I think it's great for having a baseline, also for pre-production. Like, I like the way of when you're in production, getting automatically some observability, information of observability, using them to recreate synthetic tests, and then use it, for example, in your pipeline, as well as to monitor. I think it depends on the use case. In production, it's also helpful to see if you're more on the network side to make sure that you get a good network from all over the places, and there are still relevant. What's your take? What do you think about it?
We have another question here.
I don't see it. Here on top at the light.
There's the light
it's invisible. So you can ask whatever you want to ask. We will never see you.
So people, well, normally they see me. But my question is, you said you use observability to find out what your users do with the API.
Mm-hmm.
I think that's a supporting instrument, but from my viewpoint, the best thing would be talking to your users.
Yeah, of course.
So what's your take on that?
Yeah,
because
so I'm all about talking. So I love to talk about users. Sometimes it helps you to spot things like, and it depends if you are in B2C or B2B. If you're in B2C, you have lots and lots of customers, and you want maybe to use observability to see what are interesting users I want to talk to, either people that are not using it at all or using a lot, and then it helps you to filter who do you want to talk to. If you are in the B2B, usually you get anywhere more customer contact, but the data doesn't lie. So when you talk with user, they might say something or forget something, or it might take time to find the right user. Because in B2B it's really complicated. You have the team that works with that, and then the developer. So it's a help more. I would say data and people is a good combination. You're right.
Hello. Thank you for the talk. So you mentioned, I think, before you got started, when you got started, you had several in-person user sessions.
Yeah.
Was that correct?
Yeah.
So did those user sessions drive the way you modeled your observability stack? Or was it to verify your observability stack? Or how did one kind of influence the other?
Yeah, so we went through, so we didn't want to just, in our API gateway, just implement OpenTelemetry and say, oh, okay, it's there. We want to make sure that we really understand how it can help our users. So what we did, we started working first on a very quick demo, really rough, really POC. We used the OpenTelemetry demo for that. So there is an OpenTelemetry demo from the community. We just added tag gateway, and then we went to customers and we showed to them, and we started to have those discussions. And based on that, we modeled some of the data we are sending on adding on the traces, and that helped us to really provide good quality data, not just data, but making sure that it helps our users.
Awesome. Thank you.
Any further questions?
I may have one. Hi. You mentioned that you all at Tyke instrumented the GraphQL in the way that the spans would produce errors or not. Do you see that in the future that GraphQL provides that to the user?
Yeah, I'd love to. And we started a GitHub issue on the semantic convention of OpenTelemetry with other GraphQL member of the community, because that's something that I feel really passionate about, that we should have good semantic convention so that then people get in the observability tools the data they need. So
Awesome.
give me a thumbs up on that issue.
Will do.
Okay,
Wait,
One more here.
one more, perfect.
Just a quick question. First of all, thank you for the talk. Tyke is so everybody knows everybody likes money. But is this combination of Tyke and OpenTelemetry, is it open to the public and free, or is it?
It's open source. It's the tag gateway is fully open source, even authentication, weight limiting. What we sell is the management plan, the control plan with the dashboard as a user interface, but the API gateway is part of that landscape, CNCF landscape we saw in the talk earlier, and it's free for everybody to use. We have a community, so feel free to try it and let us know.
Okay, thank you.
And take stickers. They are really cool stickers.
Okay, so I think then we can go into break. We have now nearly 30 minutes, 25 minutes break. Till then, Patrick and Florian will join the stage to talk about scaling Kubernetes across multiple teams in a huge enterprise. So looking forward to this one. Enjoy some beverages out there, enjoy some food, enjoy some drinks, have some conversations. I think you're around for quite a while still here today and also tomorrow.
Yeah, tomorrow. Today I have to go a bit earlier because childcare duty, but tomorrow I'll be here the whole day.
Cool, then reach out to Sonja if you have any further questions. And yeah, one final round of applause for her. Thanks a lot, Sonja.